Sandra, you are the technical lead of the pilot experiment of Additive Industries in Change2Twin project. Why did you decide to acquire a digital twin for your company?
Yeah, thank you, Marcella, for the question. At Additive Industries, we're making metal additive manufacturing machines, which are called the Metal Fab 1. And for our customers who are using the Metal Fab 1, it's very interesting to look at different methods for quality control, because currently the most common ways of doing quality control is either with destructive methods or having very expensive methods as well. And one of the things where digital twin can help with is really having another approach to quality control as well. So that's why we decided to join the Change2Twin project as well, and see where it could lead us in order to provide a solution for our customers as well in quality control.
Sandra, and can you tell us something more about the digital twin you are building up?
So what we do is basically an approach from all the sensors we have in our machine as well, and also having inline quality control. So we have a system in our Metal Fab 1, which is looking inline to the process itself. And we try to combine all kinds of different sources of data in order to train really the machine learning model, which one of our partners is building as well, Syntef. To have it trained in the right way, because it's really difficult to really detect defects, because in metal additive manufacturing you're interested in really defects in the part itself. So that's why we're now trying to build up step-by-step data sets in order to train the digital twin and the machine learning model in such a good way that it can, in the end, recognize all kinds of different type of defects as well, and serve the customer as best as it could be in recognizing that whole library landscape of things that could happen in the metal additive manufacturing process, because it's quite a complex and challenging production method in the end, where we still are learning bit by bit, step by step. So it's for us and our partners, I think currently a journey of building the data set, seeing what the best approach is and what kind of methods we should use to analyze the data as well, to get in the end a good representation of what we can do for quality control as well. So it's always very interesting to see what kind of approaches we already took down the line in here in order to come to something tangible as well.
And Sandra, how are you progressing?
Yeah, we of course we had some challenges in the beginning, meaning that we were looking for how we can build a data set very good, because you need some different types of data in order to train the model in such a good way that it is capable of recognizing the defect as well. And for us, it was in the beginning quite a challenge to see how we should approach that, and which angle we should take upon this challenge as well. So we did it from several aspects. And I think currently what we do is building up our data set in order to make sure that we have a good representation of what the production process should look like. And we were now extending that data set as well. In the meantime, our other partners like Unit 40 are also building up the visualization methods, and they're now also in the rounding off phase. So on one end, we're still building up the data set to train bits of the quality control model, and on the other hand, we're already progressing with the visualization of it. And one of the last steps will be combining these types of data as well. But all in all, it's been an interesting journey, because in the beginning some challenges, and we're still learning from it to see how we could either extend the data set or discuss if we have a good representative data set as well.
Sandra, thank you very much for the interview and good luck with your experiments.
Yeah, thank you very much, Marcella.